Hello friends, welcome back to Amrita's Bling. Today we are going to look at practice problems on permutation and combination. This is fourth video from the series. Today we'll see problems based on factorial notation. Factorial notation. Evaluate 5 factorial. Now this is a factorial sign and we have to calculate the numerical value of 5 factorial. Now we know that n factorial is equal to n into n minus 1 into n minus 2 up to 3 into 2 into 1. As in, whenever we are referring to n factorial, basically we need to refer all the natural numbers from n till 1 and multiplication of all these natural numbers. So 5 factorial is equal to 5 into 4 into 3 into 2 into 1, which is nothing but 120. Evaluate 7 factorial. Now similarly, the way we have calculated 5 factorial, again n factorial is equal to n into n minus 1 into n minus 2 up to 3, 2 and 1. So similarly 7 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1, and which is nothing but 5040, that is 5040. Evaluate 7 factorial minus 5 factorial. Now this problem you can solve in two different ways. 7 factorial and 5 factorial are comparatively smaller numbers, so we can directly find out the value of 7 factorial and 5 factorial and subtract it, or whatever is the operation asked, we can perform the operation on this. So 7 factorial minus 5 factorial is equal to 5040, which we have just calculated. 5040 minus 120, which is nothing but 4920, that is 4920. Now here 7 and 5 are comparatively smaller numbers, so even without calculator we can find out the exact value of 7 factorial and 5 factorial. But let's say whenever the numbers are a bit bigger and you are not able to find out the exact value with the help of multiplication, and it may be a bit time consuming. So at that time what we can do is another method. So 7 factorial minus 5 factorial. Now what we will do is we will split this 7 factorial up to 5 factorial, as in we will split the bigger number up to the factorial of smaller number. So 7 factorial we will split into 7 into 6 into 5 factorial minus 5 factorial as it is. Now this 5 factorial we will take out as common part. So in the bracket we will be having 7 into 6, that is 42, and as this 5 factorial we have taken out common outside the bracket, then 5 factorial divided by 5 factorial is 1. So the number remaining is 5 factorial into 42 minus 1, that is 5 factorial into 41. Now we know that 5 factorial is 120 and 42 minus 1 is 41. So 120 into 41, which is equal to 4920, that is 4920. So in either way you can calculate the value of 7 factorial minus 5 factorial. I hope you have understood the standard method where we split the numbers up to smaller factorial. Now we need to find out the ratio of 7 factorial upon 5 factorial. This is comparatively easy rather than the previous problem. Here also we will split the bigger factorial to the smaller factorial. So 7 factorial we will split as 7 into 6 into 5 factorial whole divided by 5 factorial as it is. Now as all these terms are multiplied to each other, we can simply cancel out 5 factorial and 5 factorial from numerator and denominator. So we just have 7 into 6 and upon nothing, that means upon 1. So simply 7 into 6, that is 42, is the answer of 7 factorial upon 5 factorial. We'll move to next problem. Compute 12 factorial upon 10 factorial into 2 factorial. Now here also the same method we will imply, that is we will split the bigger factorial, that is 12 factorial, up to the smaller factorial, so that the smaller factorial sign will get cancelled. Now here in the denominator there are two terms, 10 factorial and 2 factorial. So whichever is bigger, it's always easy to cancel out that factorial first. So 12 factorial we will rewrite as 12 into 11 into 10 factorial, whole divided by 10 factorial as it is. Now in the same step, this 2 factorial is very easy to compute. So this 2 factorial, instead of 2 factorial we will write 2 into 1. Now again all these terms are multiplied to each other. So this 10 factorial from numerator and denominator can cancel each other. Then we'll have 12 into 11 upon 2 into 1. So this 2 ones are 2 and 2 6s are 12. So we have 6 into 11, that is 66. So ultimately 12 factorial upon 10 factorial into 2 factorial is equal to 66. We'll move to next variety of problem. Evaluate n factorial upon n minus r factorial into r factorial, where n is equal to 5 and r is equal to 2. Now here certain expression is given, that is n factorial upon n minus r factorial into r factorial. Actually this is nothing but the formula for combination, but combination part we will see later. So as of now we will consider this just as an expression. So we need to find out the value of n factorial upon n minus r factorial into r factorial, and the value of the variable, numerical value of these variables n and r is given, for which we need to find out the value of this algebraic expression, that is n is equal to 5 and r is equal to 2. So we will put the value as n is equal to 5 and r is equal to 2, then we'll get 5 factorial upon 5 minus 2 factorial into 2 factorial. So 5 factorial as it is. Now 5 minus 2 factorial is equal to 3 factorial and 2 factorial again as it is. So now again 5 factorial we will split up to 3 factorial. So 5 factorial we can rewrite as 5 into 4 into 3 factorial upon 3 factorial, and 2 factorial we will split as 2 into 1. So this 3 factorial will get cancelled, and then we have 5 into 4 upon 2 into 1. So this 2 ones are 2 and 2 twos are 4. So whatever is remaining in the numerator is 5 into 2 and denominator is nothing but 1. So 5 into 2 is equal to 10. Hence value of this expression n factorial upon n minus r factorial into r factorial for n is equal to 5 and r is equal to 2 is 10. Now this problem is a little bit different. Here the expression is given that 1 upon 8 factorial plus 1 upon 9 factorial is equal to x upon 10 factorial, and we have to find out the value of x. We will just rewrite the given expression. Now first of all we have to simplify. We will observe the given expression. On the left hand side there are two terms and on the right hand side there is just one term. So we will first of all simplify the left hand side, that is LHS. Now if you look at the LHS, we need to add two different terms in the LHS, that is 1 upon 8 factorial plus 1 upon 9 factorial. So what we will do is, in order to do this addition 1 upon 8 factorial plus 1 upon 9 factorial, now we know that these are the addition of two fractions. Now we know that whenever we need to add any two fractions, the denominator of those two fractions has to be same. So in this step we will just split all these 8 factorial, 9 factorial, 10 factorial into 8 factorial. So 1 upon 8 because that is a smaller factorial. So 1 upon 8 factorial plus 1 upon, now 9 factorial we can just rewrite as 9 into 8 factorial is equal to x upon, now 10 factorial also we can rewrite as 10 into 9 into 8 factorial. Now what we will do is, on the left hand side we will make the denominator of both the terms same in order to add their numerators. So for the first term, denominator is 1 upon 8 factorial, and on the second term denominator is 1 upon 9 into 8 factorial. So the denominators are 8 factorial and 9 into 8 factorial. So LCM of both these denominator will be nothing but 9 into 8 factorial. So what we need to do is, we need to make the denominator of the first term also 9 into 8 factorial. Now currently it is just 8 factorial. So what we will just do is, we will multiply numerator and denominator of this first term by 9, so that we will have the same denominators. So we'll have 9 upon 9 into 8 factorial plus 1 upon 9 into 8 factorial as it is equal to x upon 10 into 9 into 8 factorial also as it is. Now in the next step, on the left hand side, as denominators are same, we can just calculate the addition of numerators. So 9 plus 1 upon 9 into 8 factorial is equal to x upon 10 into 9 into 8 factorial. So 9 plus 1 is equal to 10. So we'll have 10 upon 9 into 8 factorial is equal to x upon 10 into 9 into 8 factorial. So now here what we can do is, from both these terms, the same numerator we can cancel it out, the same denominator, same terms in the denominator we can cancel it out. So 8 factorial will cancel each other, 9 and 9 will cancel each other. So we have 10 upon 1 is equal to x upon 10. Now by cross multiplication we'll get x is equal to 10 into 10, that is x is equal to 100. So for the expression 1 upon 8 factorial plus 1 upon 9 factorial is equal to x upon 10 factorial, for this expression value of x is equal to 100. Evaluate 8 factorial. Now this is exactly similar to the previous problems. So we know the formula, n factorial is equal to n into n minus 1 into n minus 2 up to 3, 2 and 1. So 8 factorial is equal to 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1, that is 40,320. 40320, 40,320. We'll move to next problem. Evaluate 4 factorial minus 3 factorial. Now here these numbers are comparatively very small, so we can directly get the values of it. We can calculate the values orally also. 4 factorial is nothing but 24, 4 into 3 into 2, and 3 factorial is 3 into 2 into 1. So 24 minus 6. By mistake I have just written 3. So it should be 24 minus 6, that is equal to 18. So answer of 4 factorial minus 3 factorial is equal to 18. Now here we need to validate, is 3 factorial plus 4 factorial is equal to 7 factorial or not. So now as we need to validate, what we need to do is, we need to find out the values of LHS and RHS separately, and then we can compare the values. So first of all we'll solve the LHS. Now 3 factorial plus 4 factorial. 3 factorial is equal to 3 into 2 into 1, that is 6, and plus 4 factorial is equal to 4 into 3 into 2 into 1, that is 24. So 6 plus 24 is equal to 30. So value of LHS is equal to 30. Now what is RHS? RHS is 7 factorial. Now we know how to calculate 7 factorial is equal to 7 into 6 into 5 into 4 into 3 into 2 into 1. This value we have already calculated in previous problems. So 5040. That means as 30 is not equal to 5040, we can conclude that 30 is not equal to 5040, hence 3 LHS is not equal to RHS, that is 3 factorial plus 4 factorial is not equal to 7 factorial. We'll move to next problem. Compute 8 factorial upon 6 factorial into 2 factorial. Now we have solved similar kind of problem in the previous part of the video. So 8 factorial upon 6 factorial into 2 factorial. Now we will split this 8 factorial up to 6 factorial. So 8 factorial is equal to 8 into 7 into 6 factorial upon 6 factorial as it is, and 2 factorial we will split as 2 into 1. Now this 6 factorial can cancel each other. So we'll have 8 into 7 upon 2 into 1. Now this 2 ones are 2 and 2 fours are 8. So we just have 4 into 7 in the numerator and in denominator is just 1. So 4 into 7 is equal to 28. Hence 8 factorial upon 6 factorial into 2 factorial is equal to 28. 1 upon 6 factorial plus 1 upon 7 factorial is equal to x upon 8 factorial. Find out the value of x. Now we have also just now solved one problem of this variety. 1 upon 6 factorial plus 1 upon 7 factorial is equal to x upon 8 factorial. Now again there are two terms in the LHS. So we will first of all find out the addition of LHS. So 1 upon 6 factorial as it is the smallest factorial. Now this 7 factorial we can rewrite as 1 upon 7 into 6 factorial is equal to x upon 8 factorial. Also we will rewrite up to 8 into 7 into 6 factorial. Now on the left hand side, one term, denominator of first term is 6 factorial and denominator of second term is 7 into 6 factorial. So LCM of both these denominator will be 7 into 6 factorial. Hence we will multiply by 7 to the numerator and denominator of the first term, that is 1 upon 6 factorial. Now 1 upon 6 factorial will become 7 upon 7 into 6 factorial plus 1 upon 7 into 6 factorial as it is equal to x upon 8 into 7 into 6 factorial. Now on the left hand side, denominators of both the terms are same, so we can add the numerators, that is 7 plus 1 upon 7 into 6 factorial is equal to x upon 8 into 7 into 6 factorial. That is 8 upon 7 into 6 factorial is equal to x upon 8 into 7 into 6 factorial. Now this 7 can cancel, this 6 factorial can cancel each other. So we just have 8 upon 1 is equal to x upon 8, and by cross multiplication now we can say that x is equal to 8 into 8, that is 64. Hence the value of this expression, that is 1 upon 6 factorial plus 1 upon 7 factorial is equal to 64 upon 8 factorial, that is x is equal to 64. Evaluate n factorial upon n minus r factorial, where n is equal to 6 and r is equal to 2. Now n factorial upon n minus r factorial is a formula for permutation of n objects taken r at a time. Permutation also we will see in next video. Now here we will just calculate the value of this expression for n is equal to 6 and r is equal to 2. N factorial upon n minus r factorial will put the given values in this expression. So we'll have 6 factorial upon 6 minus 2 factorial, that is 6 factorial upon 4 factorial. So 6 factorial we will rewrite as 6 into 5 into 4 factorial upon 4 factorial. Now this 4 factorial will cancel each other and we'll just have 6 into 5, that is 30. So the value of given expression n factorial upon n minus r factorial at n is equal to 6 and r is equal to 2 is 30. Now the same problem, we just need to find out the value for n is equal to 9 and r is equal to 5. So n factorial upon n minus r factorial, will put the values 9 factorial upon 9 minus 5 factorial, that is 9 factorial upon 4 factorial. So 9 into 8 into 7 into 6 into 5 into 4 factorial upon 4 factorial. So 4 factorial will cancel each other, and we have just left with 9 into 8 into 7 into 6 into 5, which is nothing but 15,120. 15120, 15,120. So value of the expression n factorial upon n minus r factorial at n is equal to 9 and r is equal to 5 is 15,120. In this video, we have seen problems based on factorial notation. In upcoming videos, we will see few more problems on permutation and combination. Thank you.